Alright guys, so we're going to talk now about the qualitative tests we can do in a solution for in an unknown solution, for anions. This means it is an ion with a negative charge. And that's basically what an anion is. So we're going to refer to our solution, our mystery solution, as solution X. PT is our primary test. That's the first one we do. And ST is our secondary or confirmation test. So, first thing we want to do is, and this is a suggested order, is we want to test for carbonates. You add acid, 2 molar nitric acid is pretty good, and you check for CO2. You do this by bubbling it through lime water. And it gives you this reaction. So, carbonate plus a hydrogen ion, because that's from an acid, gives you carbon dioxide gas plus water. And a confirmation for this is you could test the pH. Okay, if something has carbonate ions, its pH will be roughly between 8 and 11 depending on the concentration. So, and this is because carbonate mixes with water to make hydrogen carbonate and a hydroxide ion. Test for sulfates. So this is the next one we do. So we acidify X, that's solution X, to remove the excess carbonate. It's important. So we just add extra carbon to it, extra acid to it to remove that. And then we add barium. So once we've removed the carbonate to get rid of false positives, if we add barium ions, so barium chloride, whatever, you'll get a sulfate plus barium. Remember, we're just talking about half ionic equations, net ionic equations here. So sulfate plus barium gives you barium sulfate. You can see that's a solid. So that is a precipitate. We can test it by adding lead nitrate. And so if we add lead nitrate, we're testing for sulfates here. To acidified solution X, a white precipitate will form. Okay, if there's sulfates there, so lead sulfate is a white solid. Then we can test for chlorides. So you see, we're using some standard reactions plus some precipitation reactions here. If we acidify the original solution or filter out the previous step, okay, so that's getting rid of any carbonates or any solids which are formed here. By the way, if we acidify this, what will happen is it will send these back into solution. So anyway, that's a different story for a different day. So chloride plus silver, because we've got silver nitrate, again, a net ionic equation, will give us a solid silver chloride. That's a fairly standard test for chloride ions. And if we add NH3 and heat it in the water bath, our precipitation will disappear. Silver chloride precipitation will disappear in warm ammonia because it makes silver ammonium. That's not right. Doesn't matter. If we test for a phosphate ion, we can alkalize the original or filtered solution, either way is fine, with ammonia. Okay, so we add ammonia to make it a bit more basic. And when we do that, we add barium nitrate to it. So what we get is phosphate ion plus barium ion gives us barium phosphate, which is a solid. So that's another precipitation test. If we add silver nitrate to our original solution, again, yes, that's what X means. Yellow cloudiness, so a precipitate will form, a yellow precipitate will form if there are phosphate ions. Alright, I hope that made sense. The one thing you should be thinking about though is how to, hang on, one more thing. Carbonates, we test for that first because we want to avoid false positives. Carbonates will give us a lot of false positives in these, so we tend to do that one first. I've already said that, but yeah. As I was saying, I want you to think about how to put this into either a flowchart or a table. It's a good way of thinking of it. Often this will be done via a flowchart. You start at step A and you go all the way through. And it's nice and simple because you use standard techniques. Okay, as I was saying, I hope that made sense. If you have any questions, ask them in the comments below and we'll get back to you as quick as we can. Thanks for watching. Bye now.